And the topic that we have, it is we need to prove that what does mean by Kw and its value is equal to 1.0 into 10 raised to power minus 14. So this is a very important question, that how we can find out that this product is equal to 10 raised to power minus 14. So let's have a look. First of all, for this we must know that from where we just gain this. So you need to remember the self ionization or the auto ionization of the water. When we need to understand the self ionization of water molecule, we take only one water molecule. We take only one water molecule and we take its ionization like, and we have a look that that reaction is undergoing at the temperature 25 degrees Celsius, that is the main room temperature that we take at STP, standard temperature and pressure. So the reaction we have has fallen H2O as a liquid dissociated into its ions as H positive and OH negative, and this is as the aqueous solution. So if we need to write the equilibrium expression for this reaction, then how we can write that the equilibrium expression? So the equilibrium expression for this reaction we have Kc. It is the equilibrium constant and we have to write the product over the reactant. So we have two products, H positive ions, and we have hydroxide ions like OH negative ions. And at the bottom we have water molecule as the reactant as it dissociated into the ions. So this is the main equilibrium constant. So the second main thing, we know that the concentration of the water molecule is always constant. It is almost constant. So when we move this water molecule to the other side, we have a look at H2O. So the product of equilibrium constant and water molecule is equal to the product of the concentration of the hydrogen ions and the molar concentration of the hydroxide ions. So this is the equation that may write it as. So here we have the product of Kc into H2O. So what is the product of Kc and H2O? Mainly the equilibrium expression we have, it is Kc and into H2O, that is equal to concentration of hydrogen ions and we have the concentration of hydroxide ions. Here this product is known as, or we may write it as Kw. So by putting Kw, from where we just get the Kw, the product of Kc into the molar concentration of the water molecule, it is equal to Kw. So what is Kw? It is mainly known as the ionization constant of water molecule. It is known as ionization constant, and this constant is for water molecule. So ionization constant for water molecule, it can be as Kw. So by putting up Kw, then we get Kw is equal to the concentration of the H positive ions and the concentration of the hydroxide ions. So the mathematical product of H positive and OH negative ions, it remains constant in the water, or we can say that in the dilute solution. So the main thing, we need to keep the temperature constant. So the constant of the mathematical product of Kc and the water, we will write it as Kw. So Kw can also be expressed like this. Here we have Kw, the molar concentration of H positive and OH negative ions. Next we have seen that in many conductivity experiments, that the product or the concentration of H positive and OH negative ions, it is always equal to 10 raised to power minus 14. And how does it equal to 10 raised to power minus 14 ions? Because as H positive ions, we have its concentration H positive ions, its concentration is 1.0 into 10 raised to power minus 7, and we have a look when water molecule dissociated it produces equal amount of H positive ions and OH negative ions. So by the derivation of this we have a look that H positive ions is equal to 1.0 into 10 raised to power minus 7. Likewise, OH negative ions, it is also equal to 1.0 into 10 raised to power minus 7. So by putting up these values in this equation, we just get Kw is equal to 1.0 into 10 raised to power minus 7, and then we have 1.0 into 10 raised to power minus 7. So we have the value, or it's by solving we just get 1.0 into 10 raised to power minus 14. So this is the proof, or this is the main derivation that we done for this. So the one molecule of water produces 10 raised to power minus 7 hydrogen ions and 1.0 into 10 raised to power minus 7 hydroxide ions. So the ionization constant value for the water molecule we have 1.0 into 10 raised to power minus 14. In turn, so this derivation was done like what we have derived. We have just derived that Kw is equal to 1.0 into 10 raised to power minus 14. So this is the main derivation. As we know that if we have only one water molecule, then it produces one hydrogen ion and one hydroxide ion. So therefore we can say that the product of both these must be equal to the 1.0 10 raised to power minus 14. So we have the value 1.0 10 raised to power minus 14. We can also find the concentration of H positive and OH negative ion from this. And how we can be able to find this? We know that H positive ion is equal to concentration of OH negative ions. So we can also put over there H positive as 1.0 into 10 raised to power minus 7, and OH negative also their molar concentration is 1.0 into 10 raised to power minus 7. So this was the whole derivation, that was how we can prove that Kw is equal to 10 raised to power minus 14. You just need to write the equation for ionization of the water molecule. Then you need to keep the water concentration constant, and after that you just need to put the Kc over as Kw, and then you need to know that the concentration of H positive and OH negative ions is equal to 10 raised to power minus 14, and their product will be equal to 10 raised to power minus 14. So this is all about our today's lecture. I hope you guys understand how we can prove that the Kw is equal to 10 raised to power minus 14. As this was a simple calculation, we have just the dissociation of self ionization of the water molecule. The main thing you need you need to remember that it always produces equal amount of H positive and OH negative ions. And I hope you guys understand about this. And if you have any queries related to the topic or the derivation, you may ask in the comment section, and I will get back to you guys soon, inshallah. For that time, have a good day and Allah Hafiz.